Good evening, ladies and gentlemen. Welcome to TechGeek webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key of enhancing our performances and for our growth as professionals. With this principle in mind, TechGeek has initiated a series of webinars conducted by industry experts to get a crisp insight of various domains. Today's webinar is 19th in the series and will give insights into Java tutorial, do's and don'ts of Java programming. Our guest speaker today is Mr. Satyarth Gaur, Senior Java J2E Consultant at Dell Perot Systems. Satyarth Gaur is currently working as a Senior Java Consultant at Dell Perot Systems, Bangalore. He has 6 years of strong experience in design, development and implementation of Java and J2E applications. His experience of working in challenging Java projects for big MNCs as well as smaller startups in India and USA. Mr. Gaur has done his bachelor's in technology in computer engineering from National Institute of Technology, Rourkela, and executive MBA from Institute of Technology and Management, Bangalore. Satyarth has also attended short-term executive courses in financial management and project management from leading American universities. In his previous job, he got the chance to work with UIDA Aadhaar project for Government of India as a senior Java consultant for application security. Gentlemen, this presentation will continue for next 45 minutes and we will take your questions in the last 15 minutes. In the meanwhile, you can post your queries on techgeek.com or through the chat pane available in the webinar software. Without further ado, I introduce to you our guest speaker, Satyarth. Over to you, Satyarth.
Okay, so I hope like everybody can see my PPT. So let me start. So today we will cover like following areas, like top 10 mistakes made by Java programmers, how to detect them and how to avoid them, best practices in core Java. We will include both the good practices as well as the bad practices, and we will also throw some light on how to prepare for Java interviews and some Java exams and other stuff. So without any further delay, let me start with mistakes made by Java programmers of all levels. So top 10 errors Java programmers make. So first is accessing a non-static member variable from a static method. Most of the times, like we make this mistake, we try to access a non-static member variable from within a static method, like a main method. So when we do this, like we get a compiler error. So see the following code, which is the wrong code. So the correct way is to see, now this is the correct code where we first get the instance of the class inside the main method, and then using the instance we access the non-static variable. So in order to access a non-static variable within a static method, we try to first create the instance of the class and then try to access the variable, which is the correct way. Now second common mistake which normally we make is mistyping the name of the method when overriding. So while overriding, we sometimes mistype the name of the method. which creates entirely a new method. Even though the parameters, the name of the parameters and the return type remains the same, but if the method name is not the same, then overriding is not done and we get errors. So we have to ensure the name of the method remains the same during overriding. Third is comparison assignment. Like sometimes instead of single equal to, we use double equal to. So we have to always understand, like whenever we are comparing any two variables, like when to use single equal to and when to use double equal to. So whenever we are comparing two objects, like sometimes we make mistakes. Instead of using double equal to, we use dot equals method. We have to understand that dot equals method only compares the contents of the two objects. Suppose we are using string comparison. So we can use dot equals method instead of double equal to. Because double equal to will compare both the content and the addresses. So whenever we are comparing two objects, we use double equal to, and whenever we are comparing two strings, we use dot equals. So this is a thumb rule. Now next is like confusion over passing by value and passing by reference. We always know that passing by value is when we pass a primitive data type. In that case, whenever we pass a primitive data type in a method, only the copy of the data type is passed. So inside the method, when we are trying to modify the value, the copy is only modified. The original value is restored. So we are only working with copies during pass by value. But pass by reference is also possible in Java when we are passing an array, a vector to a function. In that case, when we are changing in the object's member variables, the changes will be permanent because we are making changes in the references and not the duplicate copy. So we have to understand when we are using pass by reference and when we are using pass by value in Java. Sometimes we make the mistake of writing blank exception handlers. So we should always understand that it is a good practice to make a try and catch exception, because you never know, like when your code, even if it looks like it's a good code, it's error free, you are using all the best practices, but it's a good practice to use try and catch, because whenever there will be an exception, you can always know the cause of the error. So sometimes the next error is like the next slide will go to. Sometimes we forget that Java is zero indexed. In C++, like we don't have this problem, but in Java, like everything starts from zero index. Whenever we are like declaring an array of string, see this slide. So it starts with the zero index. Because if you start with, say in the current example, string array equal to new string 3. If I try to do str array of 3, it will give array index out of bounds exception. So we have to always remember that it starts from 0 to n minus 1, if n is the length of the array. So we have to try to reduce these small common silly mistakes which we try to. Next is preventing concurrent access to shared variables by thread. So the best way to overcome this problem is to use the synchronizer accessor method. We always use getter and setter methods. So we see in the next slide, we are using getter and setter methods with the synchronized keyword. Thus, in this way, when multiple threads are trying to access the same variable, it may happen that one thread may modify that variable's value while other thread is trying to read it at the same time. This may lead to concurrency issues. So when you are trying to share a variable with multiple threads, then always make setter and getter methods as synchronized. Next is capitalization errors. So we have to always remember these few thumb rules, like all methods and member variables in Java API begin with lowercase letters, and all methods and member variables use capitalization. So suppose you have a variable called double value. So in the getter method, it will become get double value, where D is capital and V is capital. So This way you have to ensure that you are writing the getter and setter methods with proper variable names, proper capitalization. Next, one of the most common errors which every Java programmer makes is not catching the null pointers. So whenever we are trying to attempt to access an object and that reference is null, then a null pointer exception will be thrown. So the best way to avoid null pointer is whenever we are trying to access an object or a variable, first check if it is not null. Only when a reference or a variable is not null, try to access it or use it. In this way, and one more thing is that always try to declare and initialize a variable. If you declare and initialize an object or a variable in the beginning of the program, then the chances of getting null pointer error is minimized. We come to Java best practices now. We will see some of the bad practices in Java. Writing duplicate code is one of the bad practice. We sometimes copy paste similar set of code, that is writing same lines of code at multiple places in the same program. So instead of like duplicating the code, we can write it in a common method and call that method in other methods. Second is accessible field. It is a bad practice to use lot of accessible fields. So fields should always be private except for constants. And if you want to access a field, don't access it directly. Use the getter and setter methods. So always use the accessor method, that is the getter method, to access any field. Because directly accessing a field may lead to problems. Then using magic numbers. So we should try to avoid using magic numbers. Magic numbers are something like some hard-coded value. Instead, we can use, suppose we are using a value in a for loop. In the current example, if you see, instead of directly using the value, we can declare it as a final int constant and use the constant. So in this way, the chances of error is reduced and the code becomes more readable. So never directly try to use the constant. Instead, declare a constant as a variable, like final int x equal to say a number, instead of directly using the number in the for loop. Using temporary fields. We should try to avoid using temporary fields in a method. And if we need to access any temporary fields, we should try to like initialize it and hello? Yeah. Sorry for the delay. Like I think my slides were not moving. So we will continue from the start. Not a problem. We have just lost 10 minutes only. So I'll come again. Top 10 errors Java programmers make. So first is accessing non-static variables from a static method. As I told you that normally whenever we want to access a non-static variable from a static method like a main method, we should first try to, in the next slide you can see we try to create the instance of the class inside the main method and then try to use the non-static variable. So always try to first create the instance of the class inside the static method, and then using that instance you can access the non-static variables. So we should never try to directly access the non-static variable, otherwise it will give compiler problems. Second is mistyping the name of the method while overriding. So as I told you that normally while overriding, if I mistype the name of the method, it can create an entirely a new method, even though the parameter name and the return type remains the same. So we should be very cautious while we are overriding from a superclass in a child class. The name of the method should be the same. Third is comparison assignment. So sometimes instead of single equal to, we use double equal to, and which will give a compiler error. So in the comparison assignment, we should always use single equal to. So we'll move to next, comparing the two objects. So whenever we are trying to compare two object references, we should use double equal to. But whenever we are trying to compare two strings, which are not objects, like just two strings x and y, we can use dot equals method. So we have to make sure when to use double equal to and when to use dot equals. Though we will not get any compiler error if we use dot equals, I mean if we use double equals to instead of dot equals, but it's not a good practice in case of say string comparison, as you see in the slide. Next problem faced by Java programmer is confusion over passing by value and passing by reference. We should always note that in a function, whenever we are trying to pass a primitive data type like char, int and float, yeah, hello? Yeah. So whenever we are trying to pass the primitive data type such as a char, int, float, we are passing by value. In that case, within the function, if I change or modify that variable's value, I am only working on the copy of that. So the original value declared is still unchanged. In the next slide, we will see passing by reference. So whenever we are passing a Java object or an array reference in a function, in that case we are doing passing by reference. That is, if I try to modify the value of that array, then the original member variables get changed. Because here we are not working on a duplicate, we are working on the actual reference. Next problem is writing blank exception handlers. Sometimes we do try catch and we do not mention anything in the catch block. It's important to catch using a system.out.println e.get message, so that whether exception is thrown or not, it is a good practice never to write a blank catch. Forgetting that the Java is zero indexed. Unlike C++, in Java the arrays are zero indexed. Means the first element of the array starts from zero index. So sometimes even the seasoned programmers make this mistakes, like instead of accessing the array from 0, we try to access from say 1. So in the current example, if I try to do str array of 3, we will get an array out of index exception. So we should always try to access the array from 0 to length minus 1. Next is preventing concurrent access to shared variables by thread. So whenever you have an object or a variable which is being shared by multiple threads at the same time, you may get concurrency issues. To avoid this, the best way is, if you see in the slide, we synchronize the getter and the setter methods. So when the getter and the setter is synchronized, then the variable is controlled. So only one thread at a time can access or modify the value. So we will not get the concurrency issues. Capitalization errors. So in capitalization errors, we make this mistake, so we should always remember the rule that all the methods and the member variables in Java API begin with lowercase letters. And all methods and the member variables use capitalization. So suppose you have a variable defined as double value. So in the getter method, it will become get double value, where D will be capital and V will be capital. So the first letter of the method name, so D, that is, it is capital. If you don't capitalize it, you will get the errors. We'll go to the next slide. Most of the Java programmers make this error of null pointer exceptions. To avoid this, whenever you are trying to access any variable or any object in Java, first always check if it is not null, if its value is not null, or if the object is not equal to null. Only when it is not null, try to access it or use it. In that case, you will never make the mistakes of null pointer. Another tip is, whenever you declare an array, whenever you declare any object or a variable in a Java program, always try to initialize it to null value or to its default value. When you do this, like, you will never get errors of null pointers, or at least you can reduce the same. We will go to Java best practices now without losing the time. First, we will see some of the bad practices which we make. Duplicating the code. So instead of copy pasting the same lines of code at multiple places in the same program, which is a bad practice, suppose you want to reuse some lines of code, then take that lines of code and put it in a method and use that method in different places in your program. So that is a good way. Using accessible fields. So normally in Java, like, fields should always be private except for the constants. If you want to access a field in Java, try to access it using a getter method rather than accessing it directly. So always try to use getter and setter methods as a convention. Using magic numbers. So we try to avoid using magic numbers and instead replace it by a constant. In the for loop, you can see I have replaced this number 52 by a constant final int dex size equal to 52. Because in this way the code becomes more readable and the chances of errors is reduced. So whenever you try to modify dex size, you don't have to modify the for loop again and again. Otherwise you have to modify the magic number again and again, which is not a good practice. Then using temporary fields. So we should try to use using lot of temporary fields within a program. Then initializing the strings with new. See, whenever in Java programs you need lot of string variables. So we can directly use string str equal to the value instead of using string str equal to new string value. Because with every new operator you use lot of memory, which is not a good practice. So it is a wastage of memory resources using lot of new operator unless it is needed. Using float and double for currency calculations. So we should try to avoid this. Returning null. So instead of returning null, you can return an empty object or you can return a custom made null object. Because if you directly return null value, then you can get null pointer exceptions. So the best way is, like, suppose you have an object, then you can return new of that object instead of returning null null keyword, because it may lead to null pointer exception. If you see in the above example. We'll go to the next slide. Subclassing for functionality. So instead of using lot of subclasses, we can try to use interfaces for inheritance. Because what may happen that suppose you already have a subclass, a class A extends class B. Now you cannot use class C because you cannot extend two classes at the same time. So it's better to use interface because you can implement multiple interfaces at the same time, but you cannot extend multiple classes at the same time. So try to use as many interfaces as possible instead of using lot of subclasses. Another bad practice is using empty catch block. Never leave a catch block empty. Inside the catch block, always have e.print stack trace or return sysout e.get message or something like that. Never have an empty cache block. So sometimes we try to use try catch exceptions even when it is not needed. See, only use try catch exceptions when there is a purpose for it. If you see in the current example, there is no need to use try catch. Instead, you can use if and check if the index is less than 0 or if index is greater than equal to array size. So sometimes you can use the if condition rather than using try catch. Try catch is only needed when there are chances of really getting an exception. Excessive use of switches. So try to use excessive switch case and if.
Hello.
Because if you try to use lot of.
Yeah, Satyarth. Actually, a lot of participants are asking questions. So I thought now you should answer some of the questions here only.
Okay, yeah.
Jay Sakoswar is asking, can we say that Java is a pure object-oriented language? So would you like to answer this question?
Yeah, see, or can we take all the questions at the end because we have lot of slides to cover in 1 hour.
Okay. Also try to be a little explanative. I mean, explain the points in a better way.
Sure.
Yeah, sure. Please go ahead. Yeah.
So one of the bad practices is excessive use of switches. So we should try to use if and switch only when it is needed. Otherwise, we can consider polymorphism. That is, we can use the same method and we can overload it. So if you have in a single method, if you are using lot of switch case and lot of if statement, nested if, we can try to avoid that and instead we can overload that method. That is using the method polymorphism. Instance of. Try to avoid using this instance of operator. Static methods. See, static methods are needed when you are directly trying to access a method without creating an instance of the class. But it's not a very good design to always use the static methods because static methods cannot be overridden and cannot be overloaded. So only use the static methods when you are sure that you don't want to overload that method. I mean override that method. System.exit. Sometimes we make use of system.exit, but it should not be used in general because the whole program will get exited. System.exit you can only place, suppose in a try catch block, when there is an exception inside the catch block, you can place system.exit. In case the exception is very severe and it is a showstopper and you are sure you want to exit the program. We'll see some of the good practices in core Java. Validating your parameters. See, whenever you use parameters in a method or in a function in Java, it's a good practice that you always try to validate that parameter, like if that parameter is not null, or suppose if you are using an array and an index, so that array is not null or that index does not exceed the size of the array. So it's a good practice to validate your parameters before using them inside a method. Otherwise, you will get lot of null pointer exceptions and illegal argument exceptions and so on. So creating local copies. See, in the current scenario, if you see the code, I create a local copy. So inside the method, we try to create local copies of array list and objects and try to work on that copy, modify those values and reuse it. So this is a good way to prevent corruption. Because local variables and local copies cannot be accessed by outside classes. Modify the strings with string builder. Remember that string objects are immutable. That is, you cannot modify a string object. But string builder is mutable. That is, string builder objects you can modify. So whenever you use lot of string objects, you are wasting lot of memory resource. because every time you try to modify a string object, you create a new instance of the string object, which may lead to out-of-memory errors also. So whenever you are dealing with lot of string objects, instead try to use string builder objects, because there you can modify the string builder objects without using new memory locations. Favoring immutability. So immutability is something where nobody can modify your variables or objects. You can achieve immutability by making your fields in Java as private and final. So suppose you have a private final string x equal to Java. So that is a string which cannot be modified in an entire application. Also, one way to incorporate immutability in Java program is to providing only the getter methods and not the setter methods. Because if there is no setter methods for the outside world, then nobody can modify your variable or an object. Using final keyword. So whenever you are sure that your variables or parameters need not change in the program scope, you can use the final keyword by default. Always make it a habit to use final whenever there is no scope for that variable getting changed. Declare a variable just before the use. It's always a good practice to declare a variable and also initialize it before actually using it in the program, because it's easier to read that variable and refactor it. So always remember, whenever you use any variable or an object, first declare it and initialize it to a default value or say a null value before actually using it. So we should always try to initialize the variables whenever possible. Following the coding conventions. So if we follow the code conventions, see in Sun Java website, we see standard coding guidelines for Sun Java programmers. So if we try to follow the coding conventions and the Sun Java code guidelines, then it makes your program to be easily read and easily maintainable. And there are less chances of bugs. If a program is easy to read and easy to maintain, then of course there are less chances of getting the bugs. And changing the program in future is also an easy task. C. Referring to the objects by interfaces. Instead of declaring an array list as array list equal to new array list, the good practice is using list equal to new array list. Because list is an interface and array list is the class which implements the list interface. So we should always refer the object by interfaces rather than referring the object by class. Considering using enums instead of constants. Instead of using too many constants in your program, you can use an enum because it's easy to use, and then in a single program, enum is a separate class. So in the future, suppose you want to add more constants or more values, you can always add in the enum without changing the actual program. Closing your input-output streams. See, whenever you try to use any file input-output streams in your program, always make sure to include the finally block in your program and close that input-output stream. Because if you open an input-output stream and forget to close that stream, it is a wastage of memory resource and it's a bad practice. So always try to close the stream in a finally block. Because you know that in try catch finally, irrespective of what happens in try, you are always sure that your file streams, input and output streams are closed. Designing close to domain. So try to name your packages, try to name your classes with what you are making an application. Suppose your application is a banking application. So you can try to name your classes in the bank name dot something and the package name accordingly. So your class names, your interface names and your package names should reflect the type of the project you are doing. So another good practice is whenever you override equals method, you always override hash code method also. So always make sure that whenever equals return to true, the two objects must have the same hash code. So it's a good programming practice to always override both equals and hash code. Because if you try to override equals method in your program and forget to override hash code method, it will give errors. Especially in the scenarios when you are using maps and sets type of data structures. Writing self-documenting code. Whenever you write a Java code, try to give as many relevant comments as possible, because it makes your code easy to read and easy to understand. The comments can be class level comments as well as method level comments. So that's why it's a good practice to use Java doc at the beginning of every class and at the beginning of every method. Bubbling up the exceptions. See, if the code is not part of the user interface, it should not handle its own exceptions. So there is the good practice is you always try to throw the exceptions back to the UI and cache that exception in form of a pop-up, in form of an error page, or try to log that exception in a log file or show in the console. But never leave an exception unattended. Always try to catch it and display it as in form of an error page or a pop-up back to the presentation layer. Don't try to consume that exception within your business layer, because then how will the user know what exception occurred? Now we will come to see some of the best sites for Java examples, for code samples, tutorials and interviews. In my 6 years of being in the Java industry, I have came across thousands of sites for Java resources, but I have taken some of the best ones which really help any Java programmers, right from the fresher to an experienced one. One is roseindia.net, second one is vanilla.com, then there is java2s.com, then one is for SJP Next site is for interview preparation. Best book for preparing for SCJP exams, whether it is SCJP 5 or SCJP 6, is Kathy Sierra. You can get this ebook free from many resources in the internet. So using that ebook of Kathy Sierra, you can read it and prepare for SCJP 1.5 and 1.6. So any slide or any point you want me to describe in detail, since we have a lot of time left?
Yeah, Satyarth, there are certain questions asked by the participants. So would you like to answer those questions? Yeah. You can see the questions in your chat panel.
Okay.
Let me read the questions for you. Okay. David Zoel. Sorry.
Yeah, I can see the questions here.
Okay. So please read the questions and answer accordingly.
Okay. See, I will see one of the questions is about serialization and synchronization. See, serialization is used whenever you try to store an object in a file, or suppose you want to transfer an object from one application to another application via network. In that case, you serialize an object. So whenever an object is serialized, it makes sense because it can be transferred over the network and it can be persisted. So serialization is very important whenever data is transferred across the network, or you want to store it in a file, write to a file. Synchronization is, see, whenever multiple threads are trying to access an object or an instance or a method, then there might be problems of concurrency issues, because it may happen that one thread is trying to say modify the value of a variable, and at the same time another thread is trying to read it. So in those cases we try to use synchronized keyword over a block of code or over a method, so that only one thread can access that method at a time and all other threads have to wait. So only when this current thread exits the method and releases the control to other threads in waiting. So mainly synchronization is used to avoid concurrency issues when in a distributed application multiple threads are trying to access the same resource at the same time. See, in getter and setter methods, when I said synchronizing, it depends on the need basis when to synchronize the getter method and when to synchronize the setter method, and when to synchronize both the methods. So normally, like read, that is getter method is a read operation and setter method is a write operation. So normally it is a good practice to modify the write operation and not the read operation. But in some scenarios, we need to synchronize both the methods, getter and setter methods. See, by magic number I refer to any number which is used, suppose in a for loop or in a while loop, any controlling number. So the limit, suppose the for loop has to go to what limit? Say for I equal to 1, I less than equal to 10, I plus plus. So 10 is, I am referring as a magic number. So instead of using the magic number or the controlling number, I can make it as a constant variable, final, private final, int x equal to 10. And use x instead of 10, because instead of modifying the loop, I can modify just the constant value, which makes sense. See, the benefit of try catch finally is that mainly in my 6 years, I feel that to overcome null pointer exceptions, the best way is try catch. So whenever there is an exception and you try to catch it, then at least a program is not a showstopper. So in the exception you can catch it and then you can handle it accordingly. You can show an exception page or some error message to the user. So then things are in your control if you use try catch. Finally block is used mainly to close any resource. Suppose you have a database connection, you are trying to open a database connection. So it makes sense to close it in the finally block to optimize the memory, because memory optimization is the main thing. So because we cannot left the objects unattended, we have to close it when the work is over. And we know that finally block will always be executed irrespective of what happens in try catch block. So in this way we can ensure that we are closing the objects, we are closing the data streams, file streams inside the finally block, and thus optimizing the memory. Another tip I would like to give to all my attendees for this seminar is, whenever you try to declare an object or a variable and you have used it within your program, try to make it null in the finally block, because making an object as null in the finally block makes it eligible for garbage collection. So in that way, by making an object as null in the finally block, you are ensuring that you are asking the compiler or the JVM that, okay, yeah, I have used this object and now it is eligible for garbage collection and you can garbage collect it. So the best way is make everything as null, all the resources as null in the finally block to make the resources eligible for garbage collection. See, one of the questions is using string builder and string buffer. Of course, string buffer you can also use because internally it will use the string builder. So the question was, the issue was, instead of using lot of string objects, you try to use string builders because it optimizes the memory, because it is mutable. So in your program, if there are a lot of manipulations in the string values, try to use string buffer or string builder instead of string. Can we declare null at declaration? Of course, you can declare null at declaration. But whenever you try to use that object, you have to use that new variable. Or you have to, suppose I'm using a class x equal to null. So when I'm using that x, I have to use x equal to new x. But of course, we can declare an object or an instance or a variable or an array as null. Rather than not initializing, it's better to initialize the things as null or to their default value. Like you're declaring an array, initialize to null or to some default value. Say there is an integer array. You can store all the values as 0 at the declaration. Why interface is advantageous? See, the use of interface is that interface promotes loose coupling. So there are multiple classes. Suppose I'll take an example of a method called calculate interest rate. And there are different banks. See, every bank has a different way of calculating their interest rate. But every bank gives some interest on your money. So calculate interest rate, you can make a function and declare it in an interface. And then different bank classes can implement that method in their own way. So this promotes loose coupling because same method you are sharing across different classes, but implementation is different.
Satyarth,
Yeah.
one participant, Mohit Sabu, is asking if I want to reduce
Okay.
execution time, what points should be taken in consideration? So would you like to answer?
Can you come again? If you want to reduce.
He's asking if he wants to reduce execution time, what points should be taken in consideration?
Execution time.
Yeah.
Okay. So see, there are various ways to reduce the execution time in a program. First, you have to optimize the Java program. Try to reduce the number of static variables. Try to reduce lot of, suppose you are using lot of string variables, try to reduce it. Try to reduce the duplicate code. Whenever you're using a while loop or a for loop, try to always check the entry and the exit criteria. So there, and then try to remove the redundant code in your program, because the compiler might be executing some irrelevant code. Then there might be instances that you are declaring a variable but never using it in the program. So try to remove those undeclared, unused variables. Then there are instances that we try to import the entire, suppose java.io.asterisk. We try to import the entire IO package, but we want to use only particular class of that package. So only import that class instead of importing the whole package. So in these ways, like if you follow some of the best practices, like you can reduce execution time, because your compilation time and overall execution time will be reduced.
Another participant.
Yeah.
Hello. Yeah, another participant, Bablu Sharma, is asking what are the different ways of taking input in Java program, like buffered input and scanner.
Okay. See, input can be taken by various ways. Like see there is a scanner class is there, then buffered input rider, and see there are various ways. It makes sense like as long as you are taking the input, you are validating your input and checking it. So while accepting an input, you can accept it from the console or from the command line, and you can use also the argument, your public static void main string args. So from the command line argument, you can use args0, args1, and so on. Or you can use the scanner class, that is a good way.
Okay.
You can always use system.in.readline. This is another way of reading the input from the user from console.
Okay. Nitesh is asking, what is the reason behind using the local copies instead using the parameters passed through method?
See, in case of local copies, it depends on scenario to scenario. See, local copies, they cannot be corrupted, because suppose you are trying to create a local copy and working on it, suppose using some temporary variables, because you know that those local copies are not needed by the outside methods or outside classes. But see, if you are using if you are passing an object, say an array object in the method, and you are trying to modify that value of that object, then the original copy or the original value of that object reference is changed. So you want to use the local copy whenever you are sure that you don't want to modify the original value of the copy or the original value of that say variable or an object. But internally you want to manipulate that object or that variable's value for your some local operations or private operations. Then it makes sense to use local copy. Yeah.
Okay. Next participant is asking where to use interface and where to use abstract class.
Yeah, this is a good question. Like, see, the first thing which comes across, like, you have to understand what is interface and what is abstract class. See, abstract class cannot be directly instantiated. You have to always subclass it. Suppose you have an abstract class X and you have a class Y. Then class Y has to extend X. So, and in case of interface, like, the benefit is that you can implement multiple interfaces at the same time. But you can only extend one abstract class at a time. So suppose you are already extending an abstract class and you want some more functionalities. Now you cannot have another abstract class because you cannot extend it, because you already extended one abstract class. At that point of time, you can implement interface. So you can have something like class A extends abstract class B, comma, implements interface C. So like this. The benefit of abstract class is that you can have abstract as well as non-abstract method. But in interface, the only disadvantage is that suppose there are 5 methods in an interface and you want to only use 3 methods in your class, but you are bound to implement all the 5 methods in your class, because the logic says that if you want to implement an interface, you have to implement all the methods of that interface. So even if you don't want to use some of the methods, you have to implement it. So in that case, you use an abstract class. Yeah.
Okay, Siddharth, Vivek Tiwari is asking, which is a related question only. Can we use the parent or child classes in generic? What are the risks involved in defining such relationship?
I'll come back to this later, to this question. Can I have another question?
Manoj Valla is asking why refer to objects by interfaces is better.
See, suppose you are declaring an array list. You can always have array list X equal to new array list. But the good practice is using list X equal to new array list. So because this is a good programming practice, though it will not give error if you try to use it by class, but it's a good practice to use it by interface.
Another participant, Jatin Vachal, is asking, can you please explain concept of polymorphism?
Yeah. See, polymorphism in Java, like basically we have like overloading and overriding. So first you have to understand the overloading. See, in overloading, the same method, we are trying to duplicate it, but trying to change the implementation. So suppose you have a method in a Java class and you want to retain the name of the method. You want to use the same method again. So you can change the number of parameters, the data type of the parameters, the arguments, and the return type, while the method name remains the same. So this is like method overloading or method polymorphism. Then there is overriding in Java, where you are trying to use the same method which is defined in a superclass in your child class. The constraint is that, the prerequisite is that the signature of the method has to be exactly same as that of the superclass or the parent class. You can change the implementation, but the signature of the method, that is the name of the method, the number of parameters, the data type and the return type, and the have to be the same. Yeah. Can we have the next question?
So that Arun Biswas is asking, what is new in Java 6 comparing with Java 5?
See, lot of things have come up, like, because see in Java 6, like the generics have improved. Java 6 has been more compatible to the newer frameworks. But most of the original things have been preserved. There are more differences between Java 4 and Java 5 with the introduction of generics, with the introduction of static imports, with the introduction of type enums and those kind of things. But in Java 1.6, the less new things have been added, like, so it's more similar to Java 1.5 only.
We are getting a lot of questions. We'll try to take maximum of them. Another
Yeah, because we have
participant,
time, yeah.
Gautam Gupta, is asking, can constructor be private? If yes, then what is use of it?
See, you can make a constructor private if you don't want your class to be accessed by the outside world. So suppose you don't want other classes to directly instantiate your class, like a singleton class. In case of such classes, when you don't want outside classes to directly create instances of your class, then you can make the constructor as private. The example is a singleton class where you make the constructor as private, and instead you provide a public static method, because these static methods can be directly accessed without creating the instance of your class. So other classes will not invoke your constructor because it is private, but will still be able to use the method, static method of your class by class name dot method name. So the benefit of keeping the constructor private is that nobody can create instance of your class.
Okay. Sachit Wadhavan is asking, if I have multiple class in my program, then how would I know that in which class main method exists by just compiling it? As he doesn't know where is his main method.
Okay. See, whenever you use a main method, like, you can always put a logger inside the method or some system out println statement, so that you can always know. Actually, the good programming practice is that inside every method you try to put logger statements like inside method name and some parameter name. So at the entry point of the method and at the exit point of the method, try to have loggers or system.out.println statements, so that you can keep track of, like, because whenever your Java program is running, the first method which is compiled is the main method. That is the entry point for the Java program, for the compiler. So you have to put loggers in different classes, then you can only know.
Okay. Another participant, Mukul Gupta, is asking, what is throw and throws and when to use?
Okay. See, suppose there is a class A, so class A throws IO exception, comma, say XYZ exception. or say class A throws IO exception, and I will say comma file not found exception. So in that case, for a method at method level, at method level you can use the throws clause and define the list of exceptions which will be thrown whenever that method is called. So suppose there is a method called add. So you can have something like this: public void add throws IO exception comma file not found exception. So whenever that add will be called, you have to cache those exceptions. And throw what is used when you want to throw an exception using, suppose in the try catch block, inside the catch block, instead of catching that exception, you are throwing it back to the calling class by using throw new, say the exception or runtime exception. So throws is the keyword which is used for declaring the list of exceptions at the method level, and single throw is used for throwing an exception back to the parent class.
Okay, Utkarsh Tyagi asks, what may be the reasons and how we can avoid out of memory errors, like using a string builder?
Okay. See, if you use lot of string objects, like you are consuming lot of memory. So that's why you try to use string builder or string buffer. And the best ways to avoid out of memory exceptions is keep track of what variables and what objects you are being used in the program, and try to make them null in the finally block. Because whenever the scope of the program ends, that is the operations have been performed, the functions have been executed, and the Java compiler runs the finally block, it will make those objects as null and garbage collect them. So this is a good practice to make all the objects and all your resources as null in the finally block. That way you can optimize the memory. And try to avoid using lot of new operator, because the more number of new operator you use in your program, the more memory you are using.
Samish Srivastav asks, what is the difference between abstraction and encapsulation?
Okay. See, encapsulation is basically like data hiding, like similar set of functionalities. You are hiding it, or you are encapsulating it in a structure called class. So Java class is nothing but it contains set of related methods or similar methods and functionalities tied together. An abstraction is basically like you want to hide or abstract an implementation from the outside world. So suppose like you have an abstract class. So there are abstract methods as well as non-abstract methods. So you want to hide the implementation from the outside world, then you can make a method as say private, or you can create an abstract method. Like interface you declare the method signatures only. So all the methods are declared, but implementation is not there. So it is like abstraction, because different classes will use the same interface and will implement the same method but in their own way. Yeah.
Yeah, another question is a related one. Siva Kumar is asking, does interfaces make programs slower?
I don't think so, because I've come across many banking applications and telecom applications where especially lot of interfaces have been used. So there are many APIs in Java, like Java Messaging Service, JMS, which is built only upon lot of interfaces. So using interfaces does not make a program slow in general. In fact, it is a good practice because it provides loose coupling. Instead of using lot of subclasses and abstract classes, try to use interfaces. Next question.
Sachit Wadhwan is asking, why we pass 0 as when we use system exit. If we pass 100 is not legal.
Yeah, see, in system.exit is basically when the program wants to exit. Suppose there is out of memory error, or there a server crashes, or some fatal error occurs, some severe error occurs, then you use system.exit. So normally the convention is using 0, -1, those numbers, because the compiler will understand those inputs. If you try to put 100, because it's an inbuilt method of the system class. Just like you have a println method, system.out.println of the system class. Similarly, there is an exit method.
Rushi Patel is asking, what is JLayer in Java?
JLayer. Can you come again? What is JLayer?
Yeah, JLayer in Java, it must be used in Java
I'm
7.
not much familiar with that.
Okay.
Yeah, I'm not much familiar with that.
Utkarsh Tyagi asks what.
One more tip I want to give to all the Java programmers. Whenever you try to develop a Java program using any IDE, it may be Eclipse, it may be NetBeans or anything. Whenever you try to write a Java program, first try to set up following tools in your Eclipse or NetBeans. That is find bugs, then there is PMD, programming mistakes detector, and there is check style. So these tools enforces you to inject the best practices. Suppose you are making any error or you are doing any bad practice, these tools will give you and point those errors or bad practices automatically. And these tools are like free tools you can download from the internet. Find bugs, PMD, check style. Yeah, we can move to the questions.
Ramkrishna Chaudhary is asking, is developing Windows application appreciable in Java?
See, of course, like normally Windows application have and any desktop application have been developed in VC++, Visual C++ and C++, because that's what Microsoft and other companies, Google is using. But it is possible to use in Java. We can create an applet. We can do low-level programming in Java also, but it will be slow. C++ will be fast. I'll give you an example. See, in Java, the programs first convert to bytecode, and then it becomes executable. So first you have to spend the compilation time and then execution time. So in that way, it is a two-step process. First converting the source code to a bytecode and then converting the bytecode to the machine code, which is directly executable. But in C++, the programs are directly converted to exe file, and in that way C++ codes are faster, and they are more closer to low-level programming or assembly-level programming. See, Windows is an operating system, and operating system is a software which talks to the lower level, to the hardware. In such cases, C++ is preferred.
Okay. Another participant, Sunil Tiwari, asks, what is deadlock in Java and how to detect and get rid of deadlocks?
See, deadlock in a Java is that suppose there are two threads and one thread is trying to wait for another thread and vice versa. That is, both the threads are waiting for each other for the task to be started. So like I am waiting for you for the work to be started and you are waiting for me. So there is a deadlock situation. To overcome that, such scenarios, we try to use synchronization. We try to use method level synchronization or block level synchronization to avoid these deadlock issues. Yeah. And one more thing, like whenever we are doing the inter-process thread communication, we should always ensure the use of wait, notify, notify all. Because with the use of these methods, wait, notify, notify all, we control which thread is currently accessing the resource, which threads are waiting, and so on. So that there is no situation of deadlock. One thread, when it completes its operation, it can notify to the waiting thread that, hello, I have done my operation. Now you can, one amongst you can take control of the resource. So we should have a proper thread notify mechanism to avoid deadlocks. Yeah.
Onkar Jadhav is asking, when objects in the class are destroyed, then they are no longer available to use. Is there any method to
Yeah.
fix, or is there any fixed timer so that the objects of class will be destroyed after that time?
See, there is no fixed time. Suppose in the finally block you make an object as null, then there and you are overriding the say system.gc or runtime.gc and making that object reference as null. Here you are only ensuring, you are only requesting the JVM, Java Virtual Machine, that I've used this object, you can garbage collect it. But when it will be garbage collected and when in what order the objects will be garbage collected, that is beyond your control. It's upon the JVM to garbage collect that object which has been made as null in the finally block. So, and once that object is garbage collected, of course, like you cannot like reclaim it. But you cannot ensure that okay, in this specific amount of time or in this time span only, I want to reuse this object. I want to garbage collect it. That is beyond your control because garbage collection is automatic in Java. You can only request the JVM to start the garbage collection. But you cannot enforce Java garbage collection.
Another question is, what takes less space and performance-wise good in case of list and array?
Okay. Or can I come to this?
I mean, the question is, between list and array, which one takes lesser space and performance-wise, which one is better?
See, between linked list and array, different experiments have been taken. It has been found that when the size of the data is very huge, then linked list is preferable over the array list. Whenever there is lot of insertions and deletions in the middle of the list, say in the beginning of the list you want to add something, at the end of the list, or at the middle of the list, then linked list performs faster than array list. Experiments have shown this. But more or less, array list and linked list have the similar set of performance. Can we see the next question?
We are getting a lot of questions, but we are running out of time also. So what we would suggest, like, answer other questions which are on the site, answer those questions there only on the site techgeek.com.
Okay.
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 So thank you very much, Satyar, for your session on Java tutorial do's and don'ts of Java programming. It was indeed an enlightening session. I would also like to thank our participants for their support in making this webinar a huge success. The recording of this webinar will be available on techgeek.com by tomorrow. So see you all on next Wednesday. Thank you. Thank you very much.
Yeah, thanks a lot.